So the logic gates are made by the electronics component like diode and transistors, like diode and transistor. So we also studied about the different logics like DRL, which is diode resistor logic, DTL, which is a diode transistor logic, and the TTL, which is a transistor logic. So that all the logic we studied, and we performed the experiment by using an online platform. You can say the virtual lab. So we again today use the online platform which is virtual lab created by the IIT Bombay. So we use the virtual lab of digital electronics which is created by the IIT Bombay. So now today we have to perform the second experiment. So the second experiment, our second experiment is. So a second experiment is to implement the logic function, like again the AND gate, OR gate, NOT gate, exclusive OR, exclusive NOR, and the logical expression with the help of a NAND gate and NOR gate. So why we have to implement this all the logic by using NAND and NOR? As we can say, the NAND gate and NOR gate is known as a universal gate also. The NAND gate and NOR gate is also known as a universal gate. So why it is known as a universal gate? Because by using NAND logic, or you can say NOR logic, so by using a numbers of NAND gate and numbers of NOR gate, you can realize and implement any other gate. Like you can implement AND gate, you can implement OR gate, NOT gate, exclusive OR and exclusive NOR gate by using NAND gate. Also you can implement AND gate, OR gate, NOT gate, exclusive OR and exclusive NOR gate by using a NOR gate. So by using a single NAND gate, or sorry, by using a NAND gate and NOR gate, you can realize and you can implement any other gate. That's why a NAND gate and NOR gate is known as a universal gate. That's why the NAND gate and NOR gate is known as a universal gate. Okay. So which is our experiment number 2 actually. The configured NAND gate and NOR gate logic gate as a universal gate. So again, uh, we have to perform this experiment in a virtual lab which is created by the IIT Bombay. Then you have to search in Google that a digital electronics virtual lab by IIT Bombay. So the first link you click, it will be open, and click on the list of experiment. Now see, we have different 12 experiment. Out of 12, we already performed the experiment number 1, which is the verification and interpretation of the truth table for AND or NOT, NAND, NOR, exclusive OR and exclusive NOR logic. So now our second experiment is to realization of logic functions like AND or NOT, exclusive or exclusive NOR by using universal gate like NAND gate and NOR gate, like NAND gate and NOR gate. So see, now in a virtual lab, it is the experiment number 4. In virtual lab, it is the experiment number 4, which is realization of logic functions with the help of universal gates, NAND and NOR logic. The experiment number 2 is the half headers and full headers. So again, it is a combinational circuit. Experiment number 3 and experiment number 4 is the again half header, half subtractor and full subtractor, which is again you can say a combinational circuit. So for before that we have to study how a NAND gate and NOR gate work as a universal gate. So in which we have to study about the experiment number 4. So click on that experiment number 4. So again, it's the same thing. It will gives you about the what is the aim of the practical, then what are the theory of the practical. Then after the theory, we have to check the test. So there is a pre-test. After the pre-test, we have a procedure, then simulation, and after the completion of simulation, we have post-test. And last one, we have the different references regarding this experiment. So there are books and the links is given. So this is how the experiment will work. This is how the experiment will work. Okay. So here the aim is the realization of logic function. Now what do you mean by logic function? The logic function is nothing but the gates which we already studied. It is uh, you can say uh, AND logic, OR logic, NOT logic, exclusive OR and exclusive NOT. So the experiment is the realization of logic function with the help of universal gates like NAND gate and a NOR gate. Okay, NAND gate and a NOR gate. So you can read the aim. Aim is to implement the logic function AND or NOT exclusive or in exclusive NOR with the help of NAND and NOR universal gate respectively. So we can implement implement any other gates by using a NAND gate and a NOR gate. NAND gate and a NOR gate. Why? Because it is known as a it is known as a universal gate. It is known as a universal gates. Okay. So now go to the theory. So here in theory, wait 1 minute. So in a theory we have again what is the logic gates? It is nothing but the logic gates are the electronic circuits which perform the logical functions in which it have one or more than one input and but with a single output. Okay, but a single output. As why it is one or more than one, you can simply see the you can say not get having a one input and one output, and all other gates having a minimum two inputs. So uh, AND gate, not NAND gate, OR gate, NOR gate, exclusive OR and exclusive NOR gates having a minimum two inputs. So that's why it is written that logic gates are the electronic circuit. Why it is electronics? Because it is made by the you can say diode and transistors, and it is used for the performing with the logical functions which having a one or more than one input and produce a single output. So now starting with the non-NAND gate. Okay, so NAND gate as a universal gate. So you can see the theory. The NAND gate is actually a combination of two logic gates. A NAND gate is actually a combination of two logic gates in which how the NAND gate will work, as I already said, NAND gate is nothing but if we are connecting if we are connecting the output of the AND gate with a NOT gate, then it becomes NAND gate. If we are connecting the output of the AND gate with a NOT gate, then it becomes a NAND gate. So that's why NAND gate is actually the combination of two logic gates like AND NOT. So the output of the NAND gate is the complement of the AND gate. So what is the truth table of NAND gate? First, we have to understand the truth table of NAND gate. Let's say if we have two inputs, so we have four different possibilities of input: 0, 0, 0, 1, 1, 0, and 1, 1. 0, 0, 0, 1, 1, 0, and 1, 1. Here, it is the NAND gate. Okay. So you can see the output of the NAND gate is the complement of the AND gate. As the output of the AND gate is 0, 0, 0, 0, 1, 0, 1, 0, 0, but 1, 1, 1. So when all the inputs of the AND gate is high, then and then it will give you the output 1. But what is the output of the NAND gate? If all the inputs of the NAND gate is high, then and then it will give you the output 0. Then and then it gives you the output 0. Otherwise, it gives you the output 1. Okay, for all other combination, it gives the output 1. For 0, 0, it gives 1. For 0, 1, it gives 1. For 1, 0, it is gives 1. For 1, 1, it gives 0. And you can see what is the equation of the NAND gate is, if we have two input A and B, then the equation of the NAND gate is y is equal to AB bar. Y is equal to AB bar. So what bar indicates? Bar indicates the complement sign. Bar indicates the complement sign. Okay. So the first one is we have to implement NAND gate as a NOT gate. NAND gate as a NOT gate. So now NAND gate having two inputs, but for NOT gate we require single input only, because NOT gate is the gate which having single input and single output. But NAND gate we have with two inputs. So what we are doing, we are connecting both the inputs together. We are connecting both the inputs together as shown in the figure, and we are giving a single input only. And we are giving a single input only. So how it works, if you are giving the single input to the NAND gate, then the equation of NAND gate you can see here, which is highlighted. The equation of the NAND gate, actually it is AB bar. It is AB bar. But here the input is same. A, only single input. So equation is A into A. So A into A. Now what is the value of A into A? A into A is not A square. A into A is A square in mathematics, but in digital electronics, A into A is A only. Why is it so? A into A is A. Suppose you have A is equal to 0. Then 0 into 0 is 0 only. So if A is equal to 0, then your output is A only, because it is 0. And suppose if you have A is equal to 1, because here we learn about the digital fundamentals which work on the binary numbers only, which having two possibilities only, either it is a 0 or it is a 1. So suppose if A is equal to 0, then 0 into 0 is 0 only. So A into A, again A. And suppose if you have input 1, if you have input A is equal to 1, so 1 into 1, so 1 into 1, again it is 1 only. So again A into A is A only. Okay. So the equation is of the NAND gate is y is equal to AB bar, but instead of B we have A. So A dot A bar, but A dot A is equal to A only. So my input is A and it gives the output A bar. So what how it work? It work as a NOT gate only. It work as a NOT gate only. So that's why you can realize the NAND gate, but you can realize the NOT gate by using a NAND gate. You can realize the NOT gate by using a NAND gate. How you can realize? You have to connect both the input together and give a single input. Why? Because NOT gate having a single input and single output. So this is the circuit. This is the now the next one is NAND gate is a AND gate. Okay, NAND gate is a AND gate. So now we have to realize the AND gate by using a NAND gate. Now what is NAND? NAND is the simply you can say 1 minute. Sorry for the inconvenience. There are some network issue. So now we have to implement NAND gate. Now what is NAND gate? First you can see here. If we are connected gate, then it becomes NAND gate. So what we are doing now? So now we have a NAND gate. Okay. So what? How the NAND gate will be made? NAND gate is nothing but if we are connecting a node ahead of the N. Now what we are doing? If I am putting another node ahead of the head, so what it becomes, this node and this node is cancel out. Why it will so? If you can see simply, if you have a one node gate, and now I am connecting another node gate. So suppose you can see, suppose here my input is 1. So what it gives here? A node convert 1 into 0. Again another net, then my output is only again 1. So if my input is 1 then my output is also 1. So this, the effect of this node and this node is cancel out each other. So if you are connecting two nodes together, so effect of the nodes are cancel out. Okay, effect of the nodes are the cancel out. Okay, so the same thing we are doing here. This is the NAND gate. Now what is this? This is the node gate only. See, just above we are creating a node gate. How we can create a node gate by using NAND gates to by using NAND gate? If we are connecting both the input together and give a single input, then our NAND gate is work as a node gate. So here I am doing the same thing. I am connecting this as a node gate. So effect of this bubble and this node both are cancel out. Both are cancel out. So finally, what we have AND gate only. So finally, what we have AND gate only. So this is the figure of AND gate by using a NAND gate. AND gate by using a NAND gate. Now the next one is NAND gates as OR gate. So we have to create OR gate by using a NAND gate. So for that we have to study about the. For that we have to studied about the De Morgan's theorems and the Boolean algebra. Again, the De Morgan's theorems and the Boolean algebra is a part of our unit number 2. It's a part of our unit number 2. So we are just taking a simple examples of that. Now what De Morgan's theorem says? Here you can see in the screen what it says AB bar. What dash indicates? Dash indicates bar. So AB bar is equal to A into B bar is equal to A bar plus B bar. A into B bar is equal to A bar plus B bar. So what is the De Morgan's theorem says? The complement of the product. So we have product and we are doing its complement. Complement means bar. A complement of the product is equal to the sum of their individual complement. Is equal to the sum of their individual complement. So what De Morgan's theorem says? AB bar is equal to A bar plus B bar. AB bar is equal to A bar plus B bar. And another laws of the De Morgan theorem is A plus B bar is equal to A bar dot B bar. So it's it says that the complement of the sum, a complement of the sum is equal to the product of their individual complement. A complement of the sum is product of their individual complement. Okay. So this is the De Morgan's theorem, and also we have some rules of the, you can say, Boolean algebra, like A dot A is equal to A. Same way, A plus A is equal to also A plus A bar is equal to 1, A dot A bar is equal to 0. So that those rules we studied in unit number 2. So now here we have to mainly focus on the universal gates. You can say a universal gates. So again, you can see here AB bar, which is highlighted, it is De Morgan's theorem. Let me zoom some. This is the De Morgan's theorem. Okay. AB bar is equal to A bar plus B bar. A complement of a product is equal to a complement of a product is equal to the sum of their individual complement. Sum of their individual complement. Okay. So it simply says AB bar is equal to A bar plus B bar. So now we have to required, if we required a plus b, if we required a plus b, then what we have to do? We have to cancel out the dash. So what bar indicates? It indicates a note. So double note, double bar is cancel out each other. Double bar is cancel out each other. Okay. So you can see in the figure what we required: a double bar, b double bar. For that we required a bar and b bar. So here I am giving an input to the a, so it gives a bar. So this NAND gate, the first NAND gate, is work as a NOT gate. Same way the second NAND gate is also work as a NOT gate. So if you are giving input A here, then it gives output A bar. If you are giving input B here, so it gives output B bar. And finally the A bar and B bar we are giving, A bar and B bar we are giving to the input of the third NAND gate. So the final equation is A bar into B bar whole bar. A bar into B bar whole bar. So like this. This is the equation. A bar into B bar whole bar. So now we have to use the De Morgan's theorem. So what the simplicity of that? A double bar plus B double bar. A double bar plus D double bar. So again bar is cancel out. So finally we have A plus B. Finally we have A plus B, and A plus B is the equation of the A plus B is the equation of the OR gate. Now the third one. Uh, હમ, હા, લેક્ચર ચાલુ છે, 2 વાગે ફ્રી થાય. તેનું તેનું ભલે આવ્યો પછી જોઈ લે મારું. Now finally we have the third one is NAND gate as an exclusive OR gate. So we have to implement exclusive OR gate. We have to implement exclusive OR gate by using a NAND gate. We have to implement exclusive OR gate by using a NAND gate. So how can we implement exclusive OR gate by using NAND gate? So for that we have to realize these equations. We have to realize these equations. Now first, what is the equation of exclusive OR gate? The equation of exclusive OR gate is A bar B plus A B bar. So this is the equation of exclusive OR gate. A bar B plus A B bar. So we have to implement that. So again, how it will be implemented? So this is the figure. This is the figure of the realization of that. Now we are giving the input at gate number 1, we are giving the input A and B. At gate number 1, we are giving the input A and B. So the equation becomes AB bar. The output of the gate number 1, we are connecting to the input gate number 2 and gate number 3. Output is connected with the gate number 2 and gate number 3. So output of the gate number 1 is connected as the input of the gate number 2 and gate number 3. And again we are giving another input to the gate number 2 is A and gate number 3 is B. So what is the output of gate number 2? A into AB bar whole bar. The dash indicates bar. Again I am saying AB dash. What dash indicates is bar. So A into AB bar whole bar. And what is the output of gate number 3? B into AB bar whole bar, B into AB bar whole bar. So how it becomes A bar B plus AB bar. So this is the realization of that. Final equation of the output is A into AB bar whole bar, B into AB bar whole bar, again a bar, final bar. So if you use the De Morgan's theorem, so what it says A B whole bar is equal to A bar plus B bar. So instead of multiplication sign here, we are converting into plus. So again A into AB bar double bar plus B into AB bar double bar. Now bar cancel out, double bar is cancel out. So what it gives A into AB bar plus B into AB bar. So again AB bar is equal to individual bar. So A bar plus B bar, and same way A bar plus B bar. Now we are multiplying the things. So A into A bar plus A into B bar. Same way A bar into B plus B into B bar. Now as I already said, A into A bar is 0 and B into B bar is 0. Why? Again it is the a Boolean expression. Why is it so? You can see, you can say suppose A is equal to 0. You can say suppose A is equal to 0. If your A is equal to 0, then your A bar is equal to 1 and multiply this thing. So 0 into 1 is 0. Suppose you can say A is equal to 1. A is equal to 1. Then your A bar is equal to 0. So multiplied 1 into 0, again it is 0. So the finally equation we have A bar B plus AB bar, or you can say AB bar plus A bar B. So this is the equation of exclusive OR gate. So this is the figure of exclusive OR gate. You require minimum 4 gate for the exclusive OR. You can also realize the exclusive OR gate by using 5 gates, 6 gates. Okay, but minimum you require 4 gate for the exclusive OR gate. The next one is exclusive NOR gate. Now tell me, what is exclusive NOR gate? Again, exclusive NOR gate is nothing but it is exclusive OR gate. The output of the exclusive OR gate is connected with the NOT gate. So what we are doing here, we have exclusive OR gate. Here we are connecting extra NAND gate as a NOT gate. So it gives the exclusive NOR gate. You see the figure here, we have 4 NAND gate. In exclusive NOR gate, we have 5 NAND gate. The same thing. Instead of here 4, there must be 5. There must be 5. Okay. So this NAND gate work as a NOT gate. So what we are doing, we are connecting a NOT gate at the output of exclusive OR gate. So it is work as the exclusive NOR gate. So again, there are lots of things you have to derive by using a Boolean expression. Now there are generalized equations also. Now there are generalized equations also we have. Suppose we have the equation, some function like C bar B into A whole bar, B bar into C into A whole bar, C into B bar into A whole bar, and finally the bar we have. So we have to implement this thing by using a NAND gate. Okay, so how we can do this thing? So this is the figure for that. What we required, see here, first we required C bar. We have to give individual gate. Okay, first we required C bar. So for C bar, what we are connecting, I am connecting a C to the NAND gate, a single input. Okay, but what we are doing, we are sorting both the input of a NAND gate and then we are giving a C as an input. So what it gives, C bar. Then we are using another NAND gate. So output of C bar is connected with another NAND gate and we have to give another input B and A. So what it gives, C bar into B into A whole bar. So the first functions we have. The next, what we require, D bar. So again same thing, we are connecting, we are taking a D as an input. We are taking D as an input. So D, again we are connecting both the input together, so it gives D bar, and we take C and A another with an AND gate. So what it gives, D bar C into A whole bar. Same way we are taking B bar and give A and C another input, so it gives C into A into B bar, C into A into B bar. And finally, all these three I am giving to the another NAND gate. So finally, we have C bar into B into A whole bar, D bar into C into A whole bar, C into B bar into A whole bar, and again a bar. So that's how we can implement a NAND logic for the various combination. So this is the figure of the NAND gate, which we can use as a NOT gate. Then we can use a NAND gate for the AND gate. Then we can use a NAND gate for OR gate. Then we can use a NAND gate by using exclusive OR gate by using NAND gate, and then we have exclusive NOR by using NAND gate. So up to this, if anyone having any doubt, they can unmute themselves and ask me a question, or you can ask me a question in a chat session. Anyone having any doubt? Jenny, Jwalan, Keyur, Nirbhay, Rajesh, Rutvi, Syam, Jay, Dhruv, Daksh, Ankit, Anand. If there is no doubt, please write down. It's clear. Then I will move forward. Okay. Now, the next topic is NOR gate as a universal gate. Now, again, what is NOR gate? But NOR gate is nothing but it is a actually the combination of NOR gate and a OR gate and a no OR gate and a NOT gate. Okay. OR gate and a NOT gate. So what we are doing, what is the NOR gate? If we are connecting the output of the OR gate, if we are connecting the output of the OR gate with a NOT gate, then it becomes NOR gate. Now the first one is NOR gate as a NOT gate. So how many input having NOT gate? Only one. And how many input are NOR gate? Two. Then what we are doing? Then what we are doing simply the same thing which we are doing in the as a NAND gate, same thing we are doing as a NOR. Okay, we are connecting two inputs of the NOR gate together. We are connecting the two inputs of the NOR gate together, and we are giving a single input only, and we are giving a single input only. Okay, so again, and then what is the equation of the NOR gate? The equation of the NOR gate is A plus B whole bar. Instead of A into B whole bar for NAND gate, we have the equation of NOR gate as A plus B whole bar. So now, as I am connecting both the input with A, you can say, so the equation is A plus A whole bar. My equation is A plus A whole bar. So again, A plus A is A only. Suppose you can say A is equal to 0. Suppose you can say A is equal to 0, then 0 plus 0 is 0 only. So A plus A is A only. And suppose if you say A is equal to 1, so 1 plus 1, as you say, 1 plus 1 is 1, 0. Or get 1 plus 1 is 1 only. If you are giving both the input with a 1, so output of the OR gate is 1 only. So 1 and 1 is 1 only. So 1 plus 1 again it is 1 only. Okay. So as A into A is not A square, it is A only. Same way A plus A is not 2A. It is again A only. It is again A only. So A plus A is equal to A. So as my input is A and output is A bar. So here A plus A is equal to A bar. Now NOR gate as a OR gate. Again the same thing as a NAND gate as a AND gate. How the NOR gate will construct? What we are doing, we are connecting the output of the OR gate, the output of the OR gate with a NOT gate. So what we have to remove, we have to remove one NOT. So what we are doing, we are connecting a NOT gate like NOR gate. We are connecting a NOR gate at the output of another NOR gate. Okay. So the second NOT gate is work as a NOT gate. Second NOT gate is work as a NOT gate. Okay. So here my input is A plus B. So output of the first NOR gate is A plus B bar, as we all know. Output of the second NOR gate, output of the first NOR gate is A plus B bar. Now again, the output of the first NOR gate I am giving combined to the another NOR gate. So what the equation becomes A plus B bar whole bar. A plus B bar whole bar. So A plus B double bar you can say. So what it does, so bar is cancel out. You can say not is cancel out. So finally we have A plus B. Finally we have A plus B. So this is the circuit of the NOR gate by using which we can implement a OR gate. So this is the OR gate by using a NOR gate. OR gate by using a NOR gate. Third one, NAND gate. So NOR gate is a NAND gate. So again for that we have to use a De Morgan's theorem. Now this is the we have two rules of De Morgan's theorem. This is the second rule. What it says, a plus b bar is equal to a bar dot b bar. What first rule says, a dot b whole bar is equal to a bar plus b bar. Okay. So here, what we are doing, we required a into b. So we are giving a first NOR gate as a NOR gate. So we are giving a input only. So it gives a bar. Then for second NOR gate, we are giving b input only. So it gives b bar. So that a bar and b bar we are giving to the third input as a third NOR gate. Then my equation is a bar plus b bar whole bar. And if our input is a bar plus b bar whole bar, then it becomes a double bar into b double bar. A double bar into b double bar. So again, bar is cancel out. You can say double bar is cancel out. So final equation we have is a into b. Final equation we have is a into b. So again, a into b is the equation of the AND gate. A into b is the equation of the AND gate. Okay. Now the third one is NOR gate as a exclusive NOR gate. NOR gate as a exclusive NOR gate. So for that, again we have to use a different combination. So this is the same circuit like a NAND gate work as a exclusive OR gate. Here we have four NAND gates. If you remember the first one, see this is the figure. Now if you replace a NAND gate with a NOR gate, then it becomes exclusive NOR gate by using NOR gate. Then it becomes exclusive NOR gate by using NOR gate. Okay, that's only the difference. Here we have 1, 2, 3, 4. Same way. See, same figure. Now, as a first gate, we are giving the input A and B. As first input, we are giving input A and B. So my equation is A plus B bar. The output of the first gate, we are connecting to the input of the gate number 2 and gate number 3. The output of the first gate, we are connecting at the input of the gate number 2 and gate number 3. So, and also the another input of the gate number 2 is A and another input of the gate number 3 is B. So the final equation I have A plus B bar whole bar, and the output of the gate number 3 is B plus A plus B bar whole bar. And again, the output of the gate number 2 and gate number 3 we are connecting at the input of gate number 4. So finally we have the equation like AB plus AB bar, which is the equation of exclusive NOR gate, which is the equation of exclusive NOR gate. So this is my output. Y is equal to. So we have to simplify that. So A plus B bar into B plus B bar and bar. So again these two bars are cancelled out. Again we have double bar. If you simplify the equation, then you have final equation AB plus A bar B. for simplified that those equation we have to aware about the different Boolean equations. So the same thing we solve when we studied about the Boolean equations in unit number 2. Okay. So this is the figure of exclusive NOR gate, which is exclusive NOR gate made by the NOR gate, exclusive NOR gate made by the NOR gate. Now we required exclusive OR gate by using NOR gate. So what we are doing, this is the different thing, reciprocal of the NAND gate. Now I am connecting extra NOR gate ahead of the exclusive NOR gate, then it becomes exclusive OR gate. See, there is nothing difference in the figure. So this is the figure. Now instead of 4 gate, we have 5 gates. Instead of 4 gate, we have 5 gates with us. So you can see here, we have 5 gates, and it is the same circuit of exclusive NOR, but what is the difference between that? We are connecting output of the exclusive NOR gate with one another NOR gate. So it becomes exclusive OR gate. Then it becomes exclusive OR gates. So this is the theory of the NOR gate for the universal gate. If you want to implement equations like this, then you require B bar A. So B bar C bar and E bar. So we required C bar B into A, C bar B into A, which is the last one. So what we have to do, if we require C bar B bar, sorry, C bar B bar, sorry, C into B bar into A like this, then we have to give C directly, also we have to give A directly and give the NOT gate as a NOT gate as in the input. So this is the constructing of circuit with NOR gates. Also, it will be studied in unit number 2, how we have to construct a circuit by using only NAND logic and only NOR logic. So we have totally 3 logics. We have totally 3 logics known as AOI logic. What is the meaning of AOI? The meaning of AOI is nothing but it is AND or an invert, and or an invert. So the meaning of AOI is and or invert logic. Then the second logic is known as a NAND logic, and third logic is known as a NOR logic. Okay. So up to this, if anyone having any doubt, you can ask me a question by unmute yourself, or you can ask me a question in a chat session. Up to this, anyone having any doubt? Okay. Now move forward. The next portion is pre-test. So in pre-test in here, in virtual lab, There are some wrong answers. Okay, let us check. Now you have to give the answer. Give me the answer. What is the answer of first question? The universal gate is blank. NAND gate, OR gate, AND gate, or none of the above. Either it is A or B or C or D. Okay, Jwalan gives the answer, Ankit gives the answer, Ravi gives the answer. Okay, Lisa. Okay, so almost you are giving the answer, it is A. Okay, NAND gate. The second question. The inputs of a NAND gate are connected together. Inputs of the NAND gates are connected together. The resulting circuit is OR gate, AND gate, NOT gate, or none of the above. If we have two input in a NAND gate and we are connecting it as two inputs together and we are giving only single input. So which gate it is? OR gate, AND gate, NOT gate, or none of the above? Question number 2. Give me the answer of a question number 2. If the input of a NAND gates are connected together. Okay, so we have two inputs as a NAND gate, and if we are connecting both the input together, then the resulting circuit, what is the resulting circuit is? OR gate, AND gate, NOT gate, or none of the above? Give me the answer. Anand, Ankit, Bhavesh, what are the answer is? Okay, Jwalan gives the answer. What about others?
Not yet, sir.
Okay, NOT gate. So only single answer that it is NOT gate. Now the NOR gate is OR gate, followed by which gate? So question number 3. The NOR gate is OR gate, followed by AND gate, NAND gate, NOT gate, or none of the above? Anand gives the answer C. Rajesh gives the answer B. Actually, NOR gate is OR gate, followed by NOT gate only. What is the NOR gate? The output of OR gate is connected with NOT gate, then it becomes NOR gate. So how it is NAND gate? You are connecting OR gate, the output of OR gate with a NAND gate. Or also, if you are connecting the output of OR gate with a NAND gate, then also it is, you can say, let's check the answer B. Okay, almost we are giving B, then let's check for the answer B. Now, digital circuit can be made by the repeated use of which gates? OR gates, NOT gates, NAND gates, none of the above. Okay, so C. Now, a single transistor can be used to build which gates? OR gate, NOT gate, AND gate, NAND gate. A single transistor can be used to build which gate? OR gate, NOT gate. Okay. Jwalant and Lisa gives the answer. It is Okay, what is the answer for last question? D. Rajesh used the answer D. Let's check. Now submit the quiz. 2 of 5 only. So this question is right. This question is wrong. The answer is, so 3 is wrong and 2 is right only. Again, go for the pre-test. Here is a NOT gate. The NOR gate is OR gate followed by NOT gate. The digital circuit can be made by the repeated use of the NAND gates, and for the single transistor we are using a NOT gate. If you remember the circuit, let me show you. See, which circuit having single transistor? NOT gate. Okay, so for single transistor, for all other gates we require two transistors. You see here. For AND gate we require two transistors. For OR gate, for NOR gate, for NAND gate we require two transistors. And for exclusive OR and exclusive OR we require more than 6 or 7 transistors. So now this question number 3 is wrong, and this question is wrong, but the actual our answer is right. So there is some mistake in this. Okay, suppose now for the procedure. So for procedure is select the drag for the generate the wire of the circuit and join the wire to perform the required logic, and join the wire to perform the required logic. So this is the thing. Now go for the simulation. So for that you have two options. First, either you can use the NAND as a universal logic, or you have NOR as a universal logic. So first let me do a NAND as a OR. Okay, first NAND as a OR. So when there is a NAND as a OR gate, you jump on a theory. How it works, we have to connect like this, as you see. So same way the A is connected to first, again the A is connected to same, then B is connected, and the output of A is connected to the third one, and output of this. And now we have to check. So if you click on check button, and if your connection is right, then it shows you your connection is right. Here in upside, the right connection. And if your connection is wrong, let me reset. And then you click on check. Then it shows you a wrong connection. Then it shows you a wrong connection. Okay. Now move forward next. The next is the end using NAND. End using NAND. So I am connecting here. B I am connecting here. So click on check. Then again my connection is right. Okay. So here I am sharing with you a link of that simulation. Okay, so now I request all of you. So now you have to click on that link. Like, see, suppose now I am sharing my mobile. Okay, I am sharing my screen. So now you also in my mobile screen. It is my mobile screen. I am clicking on that link. So now all of you are see my mobile screen. Now you have to perform by yourself. Suppose now I am making no as a all. So I am clicking on that. It is open. Now what I have to do, I am clicking the A, connecting with B with this. The output of these two are connecting together, and below I click on check, then it shows me a right connection. It shows me a right connection. So now each and every of you, each and every of you have to click on that link and have to show me how are you perform the experiment. Okay. So now click on the link. Okay, I'm stop sharing. I will ask you anyone to share their screen. Okay, to share their screen. Now can Jwalant you share your screen? You click on that screen. You click on the link which is shared by me. Then the same thing, same virtual lab is open and you do the experiment. Okay. All of you, please click on that link and you have to perform the experiment by yourself only. Okay, Jwalan, so please share your screen. Jwalan, please start sharing your screen.
Yes, sir.
Okay.
It's visible.
Yes, yes, it is visible.
Now I turn off the screen.
No, no. Perform the experiment. Rotate your screen and perform. Ah, yes. Okay. Now click on check.
Right.
Okay, very good. Okay, now what? What the next? No, it's wrong connection. See, there is a circle. Two circles you are creating. It is not deleted. Just go downward and click on reset. If you click on reset, it is reset. Yes.
Yes, sir.
Click
Now
on
it
check.
is right.
Yes, very good. So which gate it is? Exclusive or
Yes, sir.
click on reset.
It's not connected, sir.
Click on reset again. Okay, connect A with the first one. Okay,
Yes, sir, sir.
and again connect A with the.
This.
Wait a minute. Yes. Okay, same way B. Again, you have to click on reset.
It's not done, sir.
Okay, let me present myself. You stop your presenting.
Sir, now it's right.
Now click on that.
These are removing, sir.
Okay, stop presenting. I will show you how the exclusive or get will make.
Yes, sir.
Click on stop presenting. Okay. So this is the gate we have. So A, once see if there is yellow circle, then and then you leave the click like that. Suppose you are taking below also, it will show you the circle. See, okay. Once the circle will, there is a, when you are trying to connect, okay, I will reset. When you are trying to connect, you if you take upside also and move downward, then it shows you a yellow circle. And if it shows you a yellow circle, then and then you leave the dot. Then again click on that, and then you click check, then it is a right connection. Okay. The next example, oh, okay, we have to implement the, you can say which get it is exclusive node. So what we are doing, we are giving A here, we are giving B here, same way this A here, this B here. The output of the is first get is connected to gate number 2 and 3. Again we are connecting, and finally again we are connecting, and click on check. The connections are right. Let me do the last one also. This is the example. What we required, I required C bar. See here it is also already required. I required C bar here. So instead of B, I am connecting. Then I have B bar here, but we do not require B bar. We required B only. So once you check, it gives you a wrong connection. Okay, so reset. What we required C bar. So I am connecting C here, so it gives C bar, so C bar here. I am connecting B directly, I am connecting A directly. Again I required A downward, so I am connecting A here. Again I required A downward, so from here I am connecting A here. Okay, then I required here C, so from C I am connecting here. Then I require D bar, so for that I have to make a D bar, so here it is D bar, and then I am connecting D bar here. In last I required C here, so I am connecting C here. Then I required B bar, so how I can get a B bar, so from B I have to connect here, again from B I have to connect here, then I have a B bar, then output of all the three, and then click on check, then it's right answer. Okay, so now who's the next to share their screen? Uh, let's say um, Ruthvi. Ruthvi, can you share your screen? Hello, Ruthvi. Ruthvi Molia, can you share your screen? Hello, I'm audible or not? Hello. So, Ruthvi, are you there or not? Please share your screen. Okay, I required a volunteer from any one girl can share their screen. So, I can understand what are you doing as Jenny, or you can say Isa, Pussy, Lisa, Mahima, and Ruthvi. There are no answer from the Ruthvi. What about others? I required anyone. As the Jwalan share their screen, you have to share your screen only. Otherwise, how can I understand what are you doing right now? Now?
Sir, I present my screen.
Okay. Can I stop my screen sharing? Let me stop. Okay, now you can share your screen.
Sir, is it visible?
Yes, yes, it is visible. Yes, your screen is visible. You are doing the OR gate by using NOR gate. Okay. One more. Okay, thank you, Jenny, for your volunteering.
Thank you, sir.
So, see, you can also perform the experiment by yourself also. Okay, you can implement anything. Here we have the experiment of NAND logic. You can also implement the you can any examples. See, this is the lengthy one. Here they are giving the outputs already. What it gives, it requires B bar. So what I have to do, I have to connect B with this. Then I required here A bar, so I have to connect here A. I required here C bar, so what I have to do, I have to connect here C. So now here what it requires, B bar, A bar. So I have to connect B bar with the B bar. Sorry, again I have to reset. Then I have to connect B bar with a B bar, A bar with a bar, and what I required here C. So from C I can connect with C. Then I what I required A bar. So here I have A bar, so I am connecting A bar here. Again in downward I also required A bar, so I am connecting A bar here. Then here I required C bar, so here I have C bar, so I am connecting C bar here. Then I require D, so I'm connecting D here. If downward A bar is already connected, I require C bar here, so I'm connecting C bar with C bar. Then I require B, so I have to take B from here. Now all the outputs are connected to the another input of the another AND gate, or sorry, NOR gate. Then this we have to connect and click on check, it's right connection. So you can do by yourself also, okay? Each and every example is very easy to perform by yourself also. Up to this, if anyone having any doubt, okay, I think all of you are doing the experiment by yourself also. Okay, I'm not asking you to present anyone now, but you have to do the experiment by yourself also. Like, see, Jolan did, Jenny did, same thing, same way you can perform the experiment by yourself. Okay, so now move forward. The next one is the post test. So again, there is uh, as it is already done by the A base, there is also some of the wrong answer given in this virtual lab. So suppose the first question, okay, all of you have to give the answer. A Boolean algebra, the bar sign indicates which operation? In a Boolean algebra, the bar signs, okay, Ruthvi gives the answer. Now Ruthvi gives the answer directly. Once I will ask about to share the screen. Okay, it's okay. The answer is C, given by the Ruthvi. Now, see, the output of AND gate with three inputs. Okay, Ruthvi, oh, you have a network issue. It's okay. Next time you have get the chance to share your screen. So okay, give me the answer for the second question. The output of AND gate with three inputs A, B, C is high when A is equal to 1, B is equal to 1, C is equal to 0. Okay, again the Ruthvi gives the answer. What about others? Okay, now third one. If a three input NOR gate, we have three input NOR gate has eight input possibilities. If we have three input NOR gate has eight input possibilities, how many of those possibilities will result in a high output? How many of those possibilities will result in a high output? 1, 2, 7 or 8? 1, 2, 7 or 8? A, B, C or D? Then you have to remember the truth table of NOR gate, which is reverse of the OR gate. Which is reverse of the OR gate. Let me tell you about the truth table of OR gate. The truth table of OR gate is 0, 0, 0. For 0, 1 it is 1, 1, 0 it is 1, and for 1, 1 it is 1. Now tell me the answer. Anyone? Anand, Ankit, what are you doing in this lab session? You are not giving any answers. Bhavesh, Daksh, Dhruv, Jay, Isa, give me the answer. What is the answer of this? Lisa gives the answer is 7. It is C. Now tell me what is the truth table of NOR gate? It is reciprocal of the OR gate. Let me show you the truth table of NOR gate. Now this is the truth table of NOR gate. It's a only one possibilities when it is high, When all the inputs are 0, then and then it will be 1. Then and then it will be high. So the question is, if a 3 input NOR gate has 8 input possibilities, how many of those possibilities will result a high output? So only one. If all the inputs is low, then and then it will be 0. So the answer is A. Now, which of the following logic operation is represented by the positive sign in Boolean algebra? It's represented by the positive sign in Boolean algebra. Inversion, and or complementation. Okay, they, Rajesh, Anand, now they are giving the answer. Okay, it's C, or function. Last one. Which of the following logic operation is represented by the star sign in Boolean algebra? The star simply it is a multiplication. So now Isa Pussy gives the answer that it is N. Now submit the quiz. See, because there is a problem in this virtual lab, it gives you the wrong answer. Our all the answer is right, then also it gives you the wrong answer. Bar sign is indicated by not only. We have only single possibilities when we have 3 or for high operation, and here the answer is N only. So all of our answer is right, then also it shows you the wrong. Okay, so there is some problems in this lab. And last we have a references. In references we have a books and also a link if you want to learn more about the you can say universal gate, which is NAND and NOR. Then you can click on the link. Sorry. Then it shows you the theory about that. See, this is the example which we studied today, and here also this is the link given. So how you will implement this link by using NAND gate and NOR gate like this. See? Okay. Same way you can use the book also. So this is the experiment number 2. I will share today only. So here what you have to do, symbolic logic diagram. So you have to draw the logic diagram for NAND gate, and here you have to draw the NAND gate and NOR gate. Then the basic gates by using NAND gate, the basic gate is AND and or NOT. So here you have to draw the AND gate, OR gate and NOT gate by using a NAND gate, and here you have to draw a AND gate, OR gate and NOT gate by using NOR gate. Then what is the procedure? You have to write down the procedure by your language. Exercise, which is I am not given right now, the conclusion, and again there is some question answers. So the question answers you have to solve by yourself only. Up to this, if anyone having any doubt, you can ask me a question in a chat session, or you can unmute yourself and you can ask me a question.